All right, so now that we kind of understand what it means to, what the domain and range of a function mean, let's find the domain. So let's talk about how we would find the domain of the function that looks like, and I'm just going to introduce you to function notation. We'll talk more about this in the next section, but let's say that. So what that says is find the domain of the function f of x equals 1 over 3x minus 7. So one thing that might be bothering you is this. That f of x simply means, is another name for y. So this is just another way of writing y equals 1 over 3x minus 7. These two statements are equivalent. The function notation you'll find in the next section just gives us a shorthand for some stuff that we do. So we're not going to stress about that. It's just a mathematical notation that we'll work more with in the next section. For today, what we want to do is find the domain of this. So I've got my two rules up there at the top of the screen. And the first rule says no division by 0. So what I know then is that the set of x values for which this function has a defined output cannot include the x value that would make my denominator be 0. So my domain must exclude the x value for which 3x minus 7 equals 0. So what I can do is I can actually write 3x minus 7 cannot equal 0. Add 7 to both sides and then divide by 3, and that's going to quickly lead us to x cannot equal 7/3. So this is a statement of the domain. A more complete statement of the domain of this would be the set of all x's such that x cannot equal 7/3. Or we can write that as x is an element of the set from negative infinity to 7/3 with an open dot or parenthesis, unioned with everything on the other side of 7/3. So this is the set of all real numbers, not including the value 7/3. If you're asked for the value which must be excluded from the domain, that value is 7/3. If you're asked to state the domain, then you would be doing one of these two things, depending on what is asked for. If you're asked for interval notation, it's this. Okay, let's try another one. Let's find the domain of the function square root 3x plus 4. Okay, now what this means, we see we've got a square root. So if we look at our two main rules, that means the domain must exclude the x value, for which the thing under the square root would be negative. Now notice that it can equal 0, it just can't be less than 0. So what we're going to do is we're going to write that 3x plus 4 must be greater than or equal to 0, because those are the allowed values. Which means that if we do a little work, x has to be greater than or equal to -4/3. This is a statement of the domain. to write this in set builder notation, you would write that the domain is a set of all x's such that x is greater than or equal to -4/3. To write it in interval notation, you realize what this means is this is a single interval that starts at -4/3 with -4/3 allowed, because you can take the square root of 0, and goes up to infinity. All right, now it's also possible to combine these two requirements, right? So you could have 1 over a function that looks like 1 over the square root of 3x minus or plus 4. And we'll get to that later. Essentially, you just have to exclude the 0 value for the most part. All right, I hope this has been helpful. We'll talk again soon. Thanks.